Hello everyone, myself Professor Chavan. We have started the fourth chapter from our Alien Science CBSE board for the subject physics. Okay. In previous lecture, we have learned about the vector addition methods. In that, we have completed the first two methods, that is the triangle method and the parallelogram method of the vector addition. Okay. Now there are some cases in which we cannot go for applying some particular cases like a triangle law or for the parallelogram law. Then in that case, what to do? How to add the vectors? Okay, so for that purpose we have to study the vector addition for the some special cases. Okay. Special cases means what? Certain conditions are there. Okay. Suppose we have the two vectors. Okay. We have two vectors that the vector A is in this direction. Okay. And also we are having the second vector, that is the vector B. Okay. That is the vector B. Now, what is the condition for the vector addition? Which are the properties required for the vector additions are both the physical quantity must be a vector and both must be of the same nature. Okay. So we are having the two vectors, the vector A and the vector B. If we have to go for the addition of these two vectors, we have to find out the resultant of the addition of these two vectors. We can go by the applying the parallelogram law. Okay. So what is the parallelogram law for the vector addition? Accordingly, what is the magnitude of the addition? That R is equal to under root of A square plus B square plus twice AB cos of theta. Okay. A square plus B square plus twice AB cos of theta. Now, in this, we have the two vectors. Okay. Suppose we have to add the vector B and the vector A. Then in that case, if we add this vector, then this total length will be according to this one. Okay, this is the vector B. Okay. This will be vector B. So how much is the angle between these two vectors here? How much is the angle? It is 0. Okay, the angle between the two vectors, that is the theta. We know what is the angle between the two vectors. It is the theta. So this theta value becomes 0. So if we put the value of theta is equal to 0 in this equation, we will get under root of A square plus B square plus twice AB into 1. Okay. Because cos of 0 is equal to 1. Okay. Cos of 0 is equal to 1. Then in that case, what is here? It is nothing but the under root of A plus B bracket square. Okay. It is the value of under root of A plus B bracket square. Okay. This value is the expansion of this bracket. So, if we remove the square root, then our value becomes R is equal to A plus B. Okay. We have the value of resultant, that R is equal to A plus B. Okay. So simply we have to find out the angle between the two vectors. If the two vectors are parallel and along the same direction. Okay. So these two vectors are parallel and same direction. Okay. These two vectors are parallel and their directions are same. Then in that case, we can apply the formula for the finding the magnitude of that particular vectors. Okay. So in that case, we will get the angle as the theta. Okay. Here theta is equal to 0. Then our equation becomes A square plus B square plus twice AB, and this is nothing but the expansion of the bracket A plus B bracket square. And if we remove the square root, our value becomes R is equal to A plus B. And this is the resultant when the two vectors are parallel and along the same direction. Okay. Now the second case, the second special case is the vectors are parallel. Okay, vectors are parallel but in opposite direction. Okay, opposite direction. So in that case, we have this vector A, okay, this vector A, and the second vector, this is vector B. Okay, first one is the vector A and second one is the vector B. Now in that case, how to apply here, which formula we have to apply? Okay, the two vectors are parallel. Okay, so angle between them will be either 0 or either 180. Okay, here both the vectors are along the same direction, but in this case the vectors are in opposite direction. So how much is the angle here? Here the value of theta will be 180. Okay, value of theta will be 180, and if we put the value of theta here in our equation of the magnitude, then we will get the final formula for the addition of such type of cases. Okay, so our formula is R is equal to under root of A square plus B square plus twice AB cos of theta. Okay, if we put here, then our value becomes A square plus B square minus twice AB. Okay, we can write here cos of theta. What is the cos of 180? It is the minus 1. Okay, cos of 180, it is minus 1. So if we put here this minus outside the bracket, what is the value of that square root? It is nothing but the A minus B bracket square. Okay, it is nothing but A minus B bracket square. So in this case, if we remove the square root, we will get the value of the resultant here. So R is equal to A minus B. Okay, R is equal to A minus B. This is the value of the resultant when the two vectors are parallel to each other but they are in the opposite direction. Okay, here the value of theta we can write here, theta is equal to 0 degree, and here theta is equal to 180 degree. Okay, theta is equal to 0 degree and theta is equal to 180 degree. The two cases are here. Now we have to go for the third case. Okay, what is the third case? That the two vectors we have to add, and for that purpose the two vectors are making some angle 90 degree with respect to each other. Okay, so what is the condition here? That two vectors are perpendicular to each other. Okay, so when the two vectors are perpendicular to each other, in this case, how we can find out the resultant? We can apply the law of triangle here. Okay, we can apply a law of triangle. Then in that case, when the two vectors we have to add, what we have to do? The starting point of the second vector will be the arrowhead of the first vector. Okay, and the resultant will give us the, by joining the initial point of the first vector and the final point of the second vector. Okay, so if we accordingly if we show this, then this is the vector A. Okay, here is the arrowhead, this is the tail end. Okay, and this is the vector B. Okay, this is the vector B. So in that case, to find out the resultant, what is necessary? That this is the perpendicular. Okay, just what is the condition according to triangle law? That we have to add the initial point of the first with the arrowhead of the second. Okay, initial point of the first with the arrowhead of the second. So this is the resultant. Okay, this is the resultant. Now if we have to find out the value of resultant here, then we have to apply the same rule of the formula of the R is equal to under root of A square plus B square plus twice AB cos of theta. Okay. So in that, the value of theta will be 90 degree. Okay. Here, the value of theta will be 90 degree. So when we put here theta, then what is our equation? Okay. So when we put here value of 90 degree, that R is equal to under root of a square plus b square plus twice ab into 0. Okay. A square plus b square plus twice ab into 0. Why 0? Because cos of theta is 0 here. The cos of 90 is 0 because theta here, theta is equal to 90 degree. Okay. Theta is equal to 90 degree. So accordingly, if we find out the value here, then the value of R will be, it is under root of a plus b bracket square. Okay. It is the under root of a plus b bracket square. So if we remove the bracket, our value becomes R is equal to a plus b. Okay. The R is equal to a plus b. So what is the value here? That R is equal to a plus b. Okay. So when we have to add the two vectors, then if we can't apply only triangle law or only parallelogram, then we have to combine the triangle law and the parallelogram law, and accordingly we have to go for the calculation of these two vectors. The addition will be given by the resultant, and that resultant is find out by knowing the angle between those two vectors. Okay. And in the first case, when the two vectors are parallel but in the same direction, then the value of theta is 0 degree. When the two vectors are parallel but in opposite direction, then the theta will be equal to 180 degree. And when the two vectors are perpendicular to each other, then in that case also the value of here, just one mistake is here, that it is nothing but the a plus b bracket square, because this value becomes 0. Okay, this value becomes 0 here, so it will be a square plus b square. Okay, so our value becomes a square plus b square, and this is the final value. Okay, this is not the required, just this is the final value of the resultant. Okay, this is the final value of the resultant. So accordingly, we can find out the value when the two vectors are perpendicular to each other. Okay. Now, if we think about the subtraction of the vectors, okay, if we think about the subtraction of the vectors, then which rules are there? Okay, so for that purpose, we will see the rules of the subtraction of the two vectors. Okay. Suppose we have the two vectors, the vector A and vector B, and we have to go for the subtraction of these two vectors. Then we have to apply the same rules as per the addition, just we have to reverse the direction of the any one vector, and accordingly we have to apply the rules for the vector subtraction. Okay. So as a vector subtraction is nothing but the vector addition by changing the sign of any one vector. Okay, so whenever we have to go for the subtraction of the vectors, then in that case, just we have to change the direction of the any one vector, and accordingly we can add these two vectors, and finally we will get the value of the subtraction. Okay, suppose we have to go for the subtraction of vector A and vector B. Okay, then if the vector A is like this, okay, this is the vector A and this is the vector B. Okay. Then in that case, whenever we have to go for the resultant for the addition or the subtraction of these two vectors, then we have to go for A plus minus B. Okay, that is, this is the vector A. In that, if we have to go for the vector B, then we have to show here vector B. Okay, this is the minus vector B, and just we have to find out this resultant. Okay, we have to find out this resultant. Then this is the vector subtraction. Okay, this is the vector subtraction. Now, if we have to go for the B minus A, okay, when we have to go for the B minus A, then we come to know that the A minus B is not equal to B minus A. Okay, the A minus B is not equal to B minus A, because if we go for the addition, then we come to know that the A minus A plus B will be equal to B plus A. Okay, suppose we take the condition of the vector addition, like if we have to add these two vectors, okay, then we will get vector A and this is the vector B. Okay, so we will get this resultant. Okay, this will be the resultant. Now, if we draw the vector B plus vector A, then this will be your resultant. Okay, this will be your resultant. Okay, sorry, this is the B and this is the A. Okay, so we check the magnitude of the resultant by changing the, this is the triangle for the, for A plus B, and this is for B plus A. Okay, this is for B plus A. Then in that case we can see that the magnitude of these two vectors are same, and also the direction of the resultant is also same. Okay, if we check the magnitude of these two vectors, then it will be same, and the direction is also in the same, because we have to start the resultant from the initial point to the initial point of the first vector to the final point of the second vector. Then in that case we have to join these two points. Also here also we have to join these 2 points, and we are getting the same value of the resultant here, the same magnitude and the same direction. Okay, but if we go for the subtraction, okay, then in that case what is happening there, that if this is the vector A, okay, this is the vector A and this is the vector B, okay, then in this case if we go for the A plus B, then our value will be like this. Okay, this will be the resultant of A plus B. But if we have to go for A minus B, then what we have to do, that we have to change the direction of this vector B. Okay, we have to change the direction of this vector B, then this will be B, and this will be the resultant of A minus B. Okay, this will be the resultant, and if we check the resultant of A plus B and A minus B, the magnitude and the direction of both the vectors are different. Okay, the magnitude and direction, both the vectors are different, because here the A plus B is having the different angle here, and A minus B is having the different angle here. Okay, so both are having the different angles. So if we check the magnitude of the resultant of A plus B and the magnitude of the resultant of A plus minus B, then our resultant's magnitude is less. That is, A plus B is always greater than A plus minus B. Okay, it's always greater than A plus minus B. So in this case, if we go for this, we can come to know that the value of A by vector plus B is always greater than A plus minus B. Okay, so this is about some special cases. Now if we think that we have the two vectors and they are having the angle 90 degree with each other, then what will happen there? Okay, what will happen there? So in that case, what will happen? Suppose we have the two vectors. Suppose this is the vector A. Okay, this is the vector A and this is the vector B. Okay, this is the vector A and this is the vector B. Then this resultant is given by the triangle law, that is the joining the tail end of the first with the arrowhead of the second. Okay, so if we join this, then A plus B. Okay, vector A plus vector B. Then if we go for the minus B, this is the vector of minus B, then in that case, if we find the resultant here, it will be A plus minus B. Okay, this is A plus minus B. So in this case, if the two vectors are having the perpendicular with respect to each other, then in that case we have the value that A plus minus B is equal to the A plus B. Okay, so in this case, if theta is equal to 90 degree, then A plus B is equal to A plus minus B. Okay, A plus B plus A is equal to A plus minus B. So we have to go for finding the angle each and every time, and we can apply the both combined rules, vector addition for the parallelogram law and the triangle law, and for that purpose if we go for the vector subtraction, then in that case also we can apply these two laws. Okay, and we will get the value of that particular resultant. Okay.